Hello and welcome everyone to my channel Code with Ease by Varsha. So we are doing a series on time and space complexity in which we cover the introduction and overview of time and space complexity. What are the different common misconceptions related to these? The characteristics of a good algorithm. Why do we even need time and space complexity? What sets it apart? Comparison of different runtimes like log n log n square, and all of that. And then a couple of code examples or snippets, and then we are going to deduce live how to get the time and space complexity out of those. So there is an entire plan of the series. So I'm hoping you guys are able to stay tuned. And please don't forget to subscribe to the channel so that you can never miss an update whenever we are posting a new video on this channel. So without further ado, let's begin. Today is the third video as part of the time and space complexity series. Today's video is going to be more hands-on, practical approach towards solving the time complexity of various code samples. In the previous two videos, we have learned a lot of theory in depth about the big O notation, how to calculate time and space complexity and all of that. So today, no theory, completely practical. We are going to do some real world examples, code snippets. We're going to see some real world code snippets and then analyze how are we going to derive the time complexity from those. So I'm hoping this video is going to build a good foundation for those who are trying to solve time complexity but don't understand how to exactly do it or find it very difficult to do it for bigger problems. So without further ado, let's get started. All right, so here we have the first question. So as we can see, there's a method, and inside this, as we can understand, the sum and the product is being calculated. So we have the first for loop where the sum is being calculated, and then we have another for loop where the product is being calculated, and then that is printed. I would recommend you guys to pause this video, think for a while what could be the time complexity for this code snippet, and then replay it to get the solution. Okay, so as many of you might have guessed, this is having two for loops, and the common mistake which people think, uh, and the common mistake which people make is whenever there are two loops, they try to think it's going to be order of n square. This is the very common mistake. But you have to see it's not the only problem with the number of loops the particular code snippet has. You also have to understand how the loops are dependent on each other. The first loop that we can see, which is computing the sum, is going through the entire length of the array. Let's say the length is n. It's going through the entire length of the array and calculating the sum. Then it is closing. We have another loop at line number 7. It's calculating again, going to the end of the array, calculating the product, and it's over at line number 9. And it is independently printing the sum in the product. This for loop is having no dependence on this for loop. Hence, if this, what is the execution of this much portion, line number 4 to 6, it's going to be n. It is going to run n times because it is traversing through the entire length of the array. What is the execution time for this for loop? Again, n times. It is traversing through the length to compute the product of the array elements. So n is over here. It's taking n time and again n time. So it is not n cross n. It is not n into n. It is not. That is wrong. Whenever two loops or two independent executions are happening, we are going to add up the number of executions. So it is n plus n, which is 2n. So what is the time complexity of this? Order of 2n. Actually, no. We don't talk of constants when we are expressing the time complexity. We drop the constants. So if I have to write the time complexity of this particular code snippet, it is going to be big O of n. This is the final answer. So whenever you see any kind of constant number, don't include that in the final time complexity. Always drop the constant, drop the unnecessary terms, which we are going to see later on, and then express the time complexity. Moving on. Print pairs. This is another method. Here, they are trying to print the pairs of the elements of this array. So again, pause the video for a while, think of the time complexity, and then replay it. Okay, so here we have two for loops again, but as we can notice, in the first for loop is the outer for loop, and then within the for loop, this for loop is not ending. Within the for loop, another for loop is beginning. So this is the classic example of nested for loops, where one for loop is dependent on the execution of the other. So let's see what's happening. The outer for loop is running from 0 to array.length. So it's running from O to N, like 0 to N. Okay, the inner for loop is again running from 0 to N, which means this inner for loop is going to run for every ith element till the end of the array. Like from 0 to n, for every element which is there in the array, this inner for loop is going to run that many number of times. And whenever this inner for loop is being invoked, it itself is running from 0 to n. So as we can understand, this is n into n, and hence big O of n square will be the time complexity of this code snippet. Moving on, print unordered pairs. Here we have two for loops. There is a condition check. Then again we are printing the pairs. Same drill. Pause the video. Think of it. What is happening inside this, and then replay. Okay, so here we have the first for loop, which is running from 0 till. Okay, so here we have two different arrays. Okay, the point to be noted. Here we have two different arrays, array A and array B. So first for loop is running again from 0 till the length of the array A. Let's say the length of array A is denoted by small a, and let's say the length of array B is denoted by small b. So again, same thing, this loop is again being nested inside. Okay, what about this if condition? What is actually happening over here? It's just a comparison between the ith element of A array and the jth element of B array. Okay, tell me if this is going to be dependent on the length of the array A or array B, will the execution time of this comparison is going to be dependent on the length of array A or array B? 1, 2, 3, 4, 5. It is not going to be. So this is something which is taking constant amount of time. Why constant? Because this anyway will be executing in every iteration. This doesn't depend on how many elements I have in my array A or how many elements I have in my array B. Okay, so this is taking constant operation. Println statements we also know constant. Okay, now what's happening outside? So for every element of array A, this inner for loop is going to run, which itself is going to run from 0 to B. The first for loop is going to run from 0 to A. So what is the time complexity of this? Big of n square. That must have been the answer of many of you. Wrong. The answer is big of AB. Okay, so not everything that you denote in time complexity is denoted by n square, n cube. What is n? N is just a variable. What is that variable? N is nothing but the length of your input. So we always try to generalize. We have this habit of saying n all the time. But that is incorrect. See what is your input. Your input is two different arrays, array A and array B. It is nowhere n is there unless you denote it by n1 and n2 or whatever. But even then, n is the length of one single input. Here you have two different input of two different length, and that is denoted by a and b, as I said in the very beginning. So the actual time complexity is big of ab. Moving on. Okay, this one is a little modification of the previous two questions that we have done. So again, pause this video, think of it for a while, and then try to replay. All right, so what's happening here? We again have array A and array B, two for loops. Oh, sorry, there are three for loops. And then we have the third for loop is trying to do, it's going from 0 to 1 lakh, and then trying to print the pairs again. Okay, so far we were seeing two for loops, and now we have another third for loop also added to it. So if the execution time of this has been like a, that I mean a is equal to the length of the array from 0 to a, and then this is also taking 0 to b, how much time is the third for loop taking then? It's running from 0 to 1 lakh. Any input involved? Is the array dot a's length or array b's length is involved? It is not. So very obviously this is taking constant space. Okay, same as what we were seeing in the comparison step over here. In the first two loops, the execution time will be considered. So this is again having a time complexity of big of a b. Moving on. So we have this method where we are checking whether the input n is prime or not. Very simple code snippet. I think many of us are already familiar with this, but we have to find out what's the time complexity of this. Okay, so pause the video, think of it, and then replay. Okay, so what is happening? We are given this input n and we are determining if this is prime number or not. For those of you who do not know what is a prime number, it's a number which has only two factors, the number itself and 1. So for example, I have this number 9. Is it a prime number? It is not, because 3 is also a factor of 9. Okay, so over here the for loop is running from starting from x equal to 2, and then we are checking if x into x is less than equal to n, and then incrementing it. Within this, we're checking the number which we're determining, that modulus this value of x is, if it is equal to 0, which means, very simple, inside this it is trying to check if it at all has any factor. If it has any factor, it is not a prime number. Otherwise, at the end, it will return true. So let's say I'll take an example. Number is 10. My n is equal to 10. So what's actually happening over here? How many times the loop is running? Okay, so let's see. So 2 into 2, 4. 4 is less than 10, yes. Is n mod 10, means 10 modulus 2. Is it equal to 0? Yes, 10 is divisible by 2, so it will return false. So there's only one step which happened and it's done. So if you notice this portion of the loop, what is actually happening is being determined by this portion. How many times the loop is going to run? The loop is going to run till x square, x into x, is less than equal to n. Okay, or in other words, we can say, if we take root on both the side, x will run till root of n times. Whatever your n is there, root of that n, whatever the value is, that many times the loop is going to run. In the worst case, that many number of times the loop is going to run. And how do we determine the time complexity? How many times the loop is going to run? That is whatever the value of x is. So it is going to run root of n times. So what we can say is, our time complexity can be big of root of n, because no matter what your n is, the worst case time complexity is that this particular code snippet will be running in this much, will be running root of n times. That's it, simple. So moving on, here we are calculating the power of two numbers a and b, which is something like a to the power b. So pause the video, think of it, and then replay. Okay, so what's happening? I told that we are trying to determine a to the power of b. So it is saying if b is less than 0, return 0. Okay, there is no point in having a negative power. B is equal to 0, return 1. Why? Because anything to the power of 0 is 1. Next, otherwise return, this is a recursive function that is going on, a into, again, power of a, comma, b minus 1. So the value of b is reduced. So let's say I have a equal to 2 and b equal to 5. So the value of b is initially 5. Then after this call, the value of b becomes 4. Then again the call happens. Again, these two conditions are not satisfied. Then the b's value becomes 3. So it goes on till it becomes 2, and then it becomes 1, and then when it becomes 0, the base case is achieved, that b is equal to 0. So it will start returning. So how many times the loop has actually run? 1, 2, 3, 4, 5. 5 times. What is 5? The value of b. So basically, this loop has run b number of times, because we are decrementing the value of b in every recursive call. So what is the time complexity then? How many times this entire code snippet ran? B times. So big of b is the time complexity for this code snippet. Moving on. Okay. So this is a Fibonacci related code, but it is not exactly the usual Fibonacci code that we see. So go through it carefully and then try to think of the time complexity. All right, so this is the Fibonacci code example. So what's happening over here is a bit lengthier than what you have usually seen, fib of n minus 1 and fib of n minus 2. Starting from this, so we have an array called memo, and then we have a for loop which is running from O to 0 to n, and then it is trying to print the return value of this method called fib, where it is taking the ith value every time, and then this array called memo. Okay, inside this fib there are base conditions that, okay, if n less than equal to 0, return 0. The usual base condition, if n equal to 1, return 1. It has another condition that if memo of n, this array's nth value is greater than 0, return that value, that array index value. Otherwise, what it is doing is it is trying to store in this array called memo the values by adding up the return value of these two method calls of the same method called fib. So it's a recursive call that it is doing. Whereas Fib of n minus 1 and fib of n minus 2 still remains the same. The only thing which is added is this memo array is being added as one of the parameters to this method. And then this is being added up, that logic also remains the same. But the only thing is it is trying to store that value inside this array. And then it is returning the the value which it is trying to store at this, and then it is trying to return. What is happening over here? Obviously, it is trying to calculate the Fibonacci numbers from 0 till n. Okay, that is clearly the case. But here the only tweak that they have done is, instead of calculating it for every number, they seem to be storing it and then utilizing it over here. Like whenever they're saying if the memo of n already exists and that is greater than 0, return that value. So if I try to give you an example, when I'm saying f of n, so when I'm saying f of 1, I know 1 is being returned because that's the base case. When I'm doing f of 2, what I want f of 1 and I want f of 0. All right. So f of 1 will return me 1. F of 0 will return me 0. So it is going to add that these two up. So 1 plus 0 is 1, and it is going to store at memo. So let's say I have this memo array, n is equal to 2. So at this location 2, it is going to store 1. So memo of 2 is now going to have 1. 1 is being stored. When I am trying to compute f of 3, what I want? I want f of 2 and I want f of 1. F of 1 will give me straight away 1. F of 2. Earlier when I had to calculate f of 2, I had to again go through this. F of 2 will be broken down into f of 1 and 0. But now, no need of that. Why? It will come to this place, this line number, and it will say if memo of n. What is memo of n? Memo of 2. Why memo of 2? Because when it is trying to call this method, it is passing in this memo array. So first the n's value is going to be 1, that is f of 1, and here fib of this 2. So n's value is 2. So memo of 2 is memo of 2 greater than 0. Memo of 2 is 1. Yes, it is greater than 0. Please return that. So this will be stored. This will be gotten from the stored value of this array. So what is the value of this 1? So you got 1 from here, and fib of 2 and f of 2 is already 1. So 1 plus 1 is 2, and it is going to be stored at memo of 3. Now you see the pattern. Every time we are going to store this value at that particular location so that I don't have to go through this entire recursive tree. I already have the pre-computed value stored at that location. This technique is called memoization and is a very efficient and optimized technique for improving the time complexity for recursive solutions, for recursive problems. Okay, especially the ones which are having worst time complexity. And Fibonacci was one of them. If you have watched my previous video, in that we have discussed how the Fibonacci sequence generator, this code, can take exponential time complexity. Okay, because of the repetitive operation that we are doing. You see, right? F of 2, why do I have to do it again? I know f of 2 is 1. Why do I have to again break it down? So now the big question, what is the time complexity? So we understood all of that. What is the time complexity? If I have to calculate f of 3, how many computations I have to do? I have to do 1. Like when I'm going through this for loop, I have to first go for f of 1 and then I get return 1. When I'm doing f of 2, I get this and I get 1 from here again. And then when I'm doing f of 3, I get the pre-computed result of 2 added to this and I again get the answer. That is 2. So how many steps I'm doing? When I'm computing for f of 3, how many steps I'm doing? Only 3. Because for every nth call, for every ith call, which is happening over here, this is just trying to extract the stored value. It is not going into any other recursive tree kind of a situation where it is trying to wait and call and then wait for the result. Nothing. Whatever it is doing, it's wrapped up in these calls only. These two base cases and in this else if. That's it. So we can say if f of 3 took 3 steps, we can say big O of n, how many, whatever the number of inputs you're having, it is going to be done in that many number of steps. It's a significant improvement from exponential time complexity, right? Where you can have 2 to the power n kind of a scenario. So I have two more questions for you as we wrap up this session, and I want you guys to comment down below the answers for this, the time complexity of this particular code snippet, as well as the time complexity of this particular code snippet. Looking forward to the answers in the comments below. Thank you so much for watching today's video. And I'm going to share this PPT in the description below. So if you found this content useful and valuable, please show your support by clicking the like button. And to stay updated on the new videos and content that we are going to put out, please don't forget to click on the subscribe button and press the bell icon to never miss an update. Thank you so much for watching today's video.